Hey guys, how y'all doing? So, listen, I am sitting outside the library. I've been here for like over 2 hours in the parking lot because if I'm home while I'm at school, my kids tear up my house. So I'll be like, oh my God, I gotta clean up. So I do not, I'll be at home like, and there's so much stuff, and my house is a hot mess right now. So much stuff I gotta do at home, but y'all, if I go home and do it, I won't study. I promise you, I'll be so distracted in here. So I am sitting outside the library. I was supposed to go in the library and use Wi-Fi and print stuff and all that other good stuff. But the library take too long to open. I drop them kids off at school in the morning and listen. So, y'all, I record my lectures, okay? Because, yeah, teacher be saying stuff. I'm like, what she say? Just won't go back to it. So anyway, I am hot. It was cold this morning. Night, you're hot. But anyway, we are doing the respiratory chapter right now, and I figure, hey, let's study together, y'all. Okay, let's study together. I'm already bringing y'all to class with me, and shout out to all of y'all that y'all be in the little lives, whatever. Hey, some free little education. Listen, you think about going to nursing school? This is what it is. Boom, put y'all on. All right. So we doing respiratory system function, data collection, and therapeutic measures. Okay. I am literally reading this textbook. Okay, and I am taking. I got my little picture I drew, taking my notes. Yeah, I am going fundamental with it. Like, I'm taking it back because I have to, because this journey has been so long. Listen, I forgot stuff along the way, and it's like I want to refresh my memory on certain things. Like, y'all, the reason I turned this little camera on, because I said, wait, I'm doing a little pH scale, y'all. So I had to do 1 through 14, neutral 7, alkaline, acid, or base, as they like to call it. And I'm just, as I'm reading, I'm dumbing the stuff down because I'm like, what? Like, they just talking to me like I'm a doctor, and I'm like, hold on. I ain't there yet. Pineapples, stop it. So y'all got my thing here. I got my upper respiratory, I got my lower respiratory. I wrote whatever, and then there's certain things about like I know the nose, the nasal cannula, what's that? No, cavity, sorry, mouth, throat, voice box. But then in the voice box, aka the larynx, the epiglottis prevents food from entering the trachea, and it's innervated by vagus and accessory cranial nerves. If I knew that, I forgot. Okay, if I may have known that in the past, I forgot. The pharynx is a ring of lymphatic tissue, destroys pathogens that penetrate the mucosa. So we're doing med surg. So this is, pathophysiology of things. So we need to know that there's something in our throat that destroys pathogens that penetrate the mucosa. And then the trachea, we know, is the windpipe that carries air from the larynx to the lungs, but just in case we forgot, we put that down, because what? I be getting all them little things confused, because throat, voice box, pharynx, larynx, trachea, listen, I don't know, I be calling the trachea, listen, they be all, I be getting confused, which one's which. I just know it's like a whole, like a thing. It's a thing down here, right? It's a tube. It's not your spine, but it's a tube, and it do a lot of stuff. So, yeah, I got my notes. Then we got the bronchi, 2 large tubes that branch off from the trachea. Trachea is the windpipe. Then we got the 2 large tubes that branch off from it and carry air into the right and left lungs. Boom. I could picture that. Boom. So much so that I drew it. Okay, we can picture it. Then bronchioles has no cartilage to maintain patency and can be closed completely. And what is this word? Oh. Can be closed completely. It can bronchoconstrict. So I'm assuming I get to this point in this chapter, but I'm so that's why asthma happens. Yeah, so you know what I'm saying? They are smaller tubes that branch off from the bronchi and carry air to the alveoli. So we have the trachea, that main tube that, right there. Then we got the bronchi. I didn't finish drawing the drawing because I traced it out the book with a pen, y'all. And she a thug. She thugging it out. Then we have the bronchi off of that. Then we got the bronchioles. I'm assuming them little branches looking things. Yes, smaller tubes that branch from the bronchi and carry air to the alveoli, the little sacs. There are millions of functional units. There are 1 cell thickness, the alveoli, to permit diffusion of gases, to permit, so going in and out. And the 1 cell thickness, I'm assuming, is very important because if it was too thick, it wouldn't permit the diffusion, you know what I'm saying? So, let's see. That's where oxygen intake and carbon dioxide, oxygen intake and carbon dioxide release. Then we have the diaphragm right there, the muscle that contracts and relaxes to help with breathing. Okay. The lungs, the lungs are big old things in the picture, occupy the thoracic cavity on each side of the heart. So y'all, I drew a little picture, look like a heart with wings. Okay. And extends from the clavicles to the diaphragm. So here, wait, what? Extending from the clavicles to the diaphragm. That's it? From here? I gotta dig deep for my clavicle. I used to go see my clavicle and feel it, but I'm like, let me dig in that hole. Let me pat it and also take where my clavicle at? Where my clavicle at? And my diaphragm. Yeah, I'm like, she gonna keep respirating every time she do it. So yeah, I'm sitting in the library parking lot, and it's better because if I would have went to the library, they'd be like, shh, gotta be quiet. And this is, I feel like, be better for me to study and. Because, y'all, I thought I was a visual learner. And I'm looking at stuff, it's looking at me. And I'm just like, well, when I look away, I forget everything I looked at. I'm like, what the hell? I don't think I'm a visual learner no more. When I was younger, I used to photographic memory. I done had a whole stroke. I can't remember nothing. Nope. Something wrong with my picture tube. Anyway, lungs. Yeah, we did that. So, respiratory centers in the brain located in the medulla oblongata and the pons innervate muscles of respiration via the intercostal and phrenic nerves. Okay, so it sends the signals on those nerves. Okay, and that's how our body knows to breathe. Okay, a normal respiratory rate is 12 to 20 breaths per minute. Y'all count them out. When I do my thing, I got my little watch. And I count the actual breaths, obviously. And what I do, because sometimes you can't see, they be breathing. I be looking. Like, I be doing the vitals, right? And they like, oh, do all that together and all that. I've been seeing it for like 50,000 years. I be like, come here. Put my hand on you. Let me pray for you in your chest. Hallelujah in the name of Jesus. Here you go. I feel it. 1, 2, 3. Like, you know what I'm saying? That's how I do it. Put my hand on them. Because they be having their hand in the little 2 cents up. Like, Let us pray. Shh. It's a silent prayer. Okay. Mind your business. But, okay, so where was that? Boom. Inhalation. As the lungs expand, alveolar pressure falls below atmospheric pressure. Oh, Lord. So I'm assuming as our lungs fill up with air, I might be wrong. Okay. I'm reading the chapter right currently. Okay. So our lungs are filling up with air, right? And the alveoli are to make space. Like it's like shh. Wait, hold on. Let me see. Look, let me hold on. Let me pat my head and rub my belly at the same time. Let me try to do this. Okay, so lungs filling with air, and then so the space could. Am I doing it right? Something like that, right? Okay. Where we at? As the lungs expand, alveoli pressure falls below atmospheric pressure, and air enters the nose and respiratory passages. A deeper inhalation requires a more forceful contraction of the respiratory muscles. I'm going to write this over, but I got a problem. My pen started fading on me. I had to get a new pen. So that's bothering me. So let me make that a little fix right there. Okay, so exhalation. So inhalation requires more contraction and all that, But exhalation is passive. Like, Process at rest, energy is not used in exhalation because no muscle contraction is required. Okay, so then we got transport of gases in blood. A total of 98% of oxygen is carried in the blood, bound. Sorry, my pen. Yo, the perfectionist in me. Bound to iron of hemoglobin and red blood cells. Oxyhemoglobin is formed in the lungs, where the partial pressure of oxygen is high. The PaO2 equals partial pressure of arterial oxygen. In the tissues where PaO2 is low, hemoglobin releases much of its oxygen. Okay, hold on. Let's make sense of that. We'll try to at least. Oxyhemoglobin is formed in the lungs. Okay, we got it. Yep. Whew, oh, Lord. Where the partial pressure of oxygen is high. In the tissues where partial pressure of oxygen is low, hemoglobin releases much of its oxygen. Okay. The remaining oxygen is dissolved into the plasma. I dumbed it down before I wrote it, so that's it. That's it. That's all. Right there. That part. Okay, CO2. Most CO2, 70%, is carried as bicarbonate ion in the blood plasma. CO2 enters red blood cells, is converted to carbonic acid. They ionize into bicarbonate ions and hydrogen ions. The bicarbonate ions leave the red blood cells for the plasma. Y'all, hold on, what I do? Oh, I wrote a little thing up here so the CO2 enter the red blood cells, and once they do that, it creates carbonic acid, H2CO3. I try to draw little bubbles and the little fumes for acid. I don't know. I think famous or whatever. Then it ionizes, removes one or more electronics. Because I forgot what the fuck that meant for a second. What the hell does that mean? It's bound over here, but then it ionizes here. It's bound to the hemoglobin there, but now it ionizes. What does that mean? So I had to write a little, in parentheses, removes one or more electrons. And after it ionizes, it becomes bicarbonate. Now, over there, it was H2CO3. Bi means two. So now the bicarbonate. And then now I got the hydrogen ions separate. Okay? There you go. All right. That's it. Got my little thing, my dumb down, because, So what now? I read down there like, what the shit? And let me tell you something. Let me show you the pages on the book. Where's the carbonic acid? You see out there. Okay, so I had to draw me a little diagram. I don't know what is she talking about, but I am sweltering. All right. Whew. Okay. So then, where we at? All right. Drew the little picture. Okay. So most CO2, 70%, is carried as bicarbonate ion in the blood plasma. CO2 enters red blood cells. It's converted. Okay, so we got CO2 over here. Then it goes. Let me use the fist. CO2, it enters the red blood cells and is converted into carbonic acid. They ionize into bicarbonate ions, bicarbonate and hydrogen ions. The bicarbonate ions leave the red blood cells for the plasma, right? The remaining hydrogen are buffered, aka neutralizing the acidity. I could talk, I swear I can. The acidity, right? We've got that hydrogen here. We're neutralizing the acidity of the hydrogen by the hemoglobin into the red blood cells. When the blood reaches the lungs, an area of lower partial pressure of carbon dioxide, these reactions are reversed. Carbon dioxide is reformed and diffuses in the alveoli to be exhaled. Why am I reading like this? Why am I not reading these words? Maybe because I wrote. Because my handwriting is pretty, but I'm in the car. I'm in the awkward position. I know I got a lot to write, so I'll be writing sloppy. So it's like when you write pretty, but you write sloppy pretty, it's like, what the fuck is this? I don't know this language over here. Hieroglyphics. So I'm like, what did I write? Hold on. Okay, carbon dioxide is reformed, and I gotta reform, and no weapon reformed against me shall prosper, because I don't know what the heck I wrote. I'm like, reformed, that don't even, and then I had the nerve to underline, what the hell? I done reformed and diffuses into the alveoli. Okay. All right, so we got that page. Wait, what's that? That's page 1. All right, so then now we on chemical regulation and respiration. Chemoreceptors. I don't like, okay, so let me tell y'all. Chemoreceptors, I'm thinking of cancer. So I'm like, boo-boo, I don't like that. I don't like that word, even though chemo is chemical, but my brain, was thinking of cancer. So chemoreceptor, and I'm like, I don't even like the word receptor. So I said, Google, what's another word for chemoreceptor? It said chemosensor. I prefer chemosensor. Generates a biological signal, okay, in the carotid and aortic bodies, okay? They detect changes in the chemical composition of the blood. Understood? We can understand that easily, right? Monitor blood levels of oxygen, carbon dioxide, and pH. The medulla responds by increasing heart and respiratory rates. Y'all, I got anyway. During hypoxemia, and I wrote the definitions of all these words because they sound alike to me. A low level of oxygen in the blood. Hypercapnia, also known as hypercarbia or CO2 retention, occurs when there's too much carbon dioxide in the blood. And or acidemia, a condition where blood becomes too acidic. I had to listen. I don't know what the hell these words be meaning sometimes, and I know you're like, well, if you know the. Listen, I do, but I don't. And my brain does this thing where it's like, what? Chemoreceptor? What we talking about? Cancer? When the oncology is going on? And then it matters how I say it too, because you know how like it could be chemoreceptor, but it also could be chemoreceptor. So if I say chemoreceptor, but I see chemo, so I say chemo, and then yeah, so whatever. All right. Respiration and acid-base balance. Respiratory system role regulating the amount of CO2 in the body fluids. Also maintains acid-base balance. Acid, oh gosh, acid alkaline pH. Any decrease in the rate or efficiency of respiration permits excess CO2 to accumulate in the blood. All right, respiratory acidosis. I gotta go slower because I'm like, what the hell am I writing to read it? Excess CO2 accumulates in the blood because you're breathing less. That's a little, you dumbing it down. Excess CO2 accumulates in the blood, resulting in excess hydrogen. Oh man. Irons lowers pH. It can occur from pulmonary disease or any impairment of gas exchange in the lungs. All right, let's go over that again. So we got respiratory acidosis. Excess CO2 accumulates in the blood. Okay. So we got a lot of carbon dioxide in the blood, resulting in excess hydrogen ions, which lowers pH. Okay, so then I go back to, I need to write a note. I go back to where area, let's see, carbon dioxide is reformed. Enters red blood cells, converted to carbonic acid, they ionize into bicarbonate ions and hydrogen ions. The bicarbonate leaves the red blood cells for the plasma. The remaining hydrogen are buffered by the hemoglobin in the red blood cells. So this is when the carbon dioxide, bicarbonate, turns into hydrogen, but because you did not, let's see if I'm understanding this. You are, I need to put inhaling and exhaling. Okay, so exhale. Eliminating. Whew. No. You are breathing less. You are, oh God, I think I confused myself. I'm hot. Whew. Too hot, y'all. Got the sweater on, I had the vest on, I got a handkerchief, I got a hat on. Among other things. Hold on, y'all. Woo! All right. Me in a tank top, y'all. Oh, cute little outfit, but listen, I'm gonna take it all off. Take it all off. This weather is annoying. What the hell is this winter in the morning? It's whew! Lord, I'm naked. All right, where was I? Okay, so respiratory acidosis. Excess CO2 accumulates in the blood because you are breathing less. Your respiratory rate is decreased. So that means it's less than, I know the answers to this, but I gotta peek. Forgive me. I know it. It's less than 12 to 20 breaths per minute. Okay. Less than that. So now you have respiratory acidosis. So I got these notes here so I can flip back and forth. All right. So don't mind me. We're studying together. We dumbing it down. We are dumbing it down. So Mara gonna come in. Like, oh my God, mommy! Oh my God! Girl, you better take some breaths. You got respiratory acidosis. Okay. All right. And she be like, girl, you got respiratory acidosis, but take the breaths over there because you got halitosis. Stop playing. Okay. All right. Anyway. Okay, so it can occur from, we know what it can occur from, bad things. All right. Any impairment of gas exchange in the lungs. All right, respiratory alkalosis occurs when the rate of respiration increases, like hyperventilating. I'm talking that. Eliminating exhaled carbon dioxide rapidly. Less CO2 in the blood means fewer hydrogen ions are formed, increasing the pH. That's why we got the pH scale here at the top. So, that's caused by hyperventilation, high altitude. So wait. Anxiety. So I can see hyperventilation and anxiety, because those will have you like. Now, watch this. Because we don't know. We need to dumb it down. We need to understand. What does high elevation have to do with respiratory alkalosis? High altitude environments characterized by hypobaric hypoxia, lower oxygen pressure, trigger hyperventilation as a primary physiological response to increased oxygen uptake. This increased breathing rate, while beneficial for oxygenation, leads to the expulsion of excess carbon dioxide, resulting in a decrease of CO2 in the blood and a shift in blood pH toward the alkaline side, which is respiratory alkalosis. The body's renal kidney system then compensates by excreting more bicarbonate to restore normal blood pH. Now, I don't know why I'm reading like this, y'all, because I had a Red Bull. Okay, you want to know what I had for breakfast? I'll be honest. No judgment. All right. So, increased breathing rate. So, I'm assuming if we was on a mountaintop, maybe unbeknownst to us, maybe we're not realizing it, we're taking in more breaths. So it's higher than 12 to 20 breaths per minute. Oh, you know what? When my fat behind walk up some steps, let me tell y'all. Oh my God, I can't breathe. So let me tell you how, if there's like more than 5 steps, let me tell you what I got to do to go up the steps. I got a hack. When I gotta walk up some steps, and it's a lot of steps, I go and I step up step, and then when both feet are on the step, I like, then I go on the step, both feet on the step, step on step, both feet on the step, and then y'all, when I get to the top of the steps, I'm not that tired. Look at me. Okay. Something wrong with me because, yeah, I need to lose some weight, but okay. I tried to go to the gym and go on the big old steps. I swear I almost fell backwards. It's like a whole little 90-degree angle. My body wasn't ready. All right, Okay, so we did okay, so it's like going up steps. Oh, all right. Lower respiratory rate equals more acidic, too much hydrogen. Okay, and a higher respiratory rate, more alkalitic, too little hydrogen. The respiratory system also helps compensate for pH changes that are metabolic, and that's where I left off before I say, hey, let me let y'all join in with me. This is a 30-minute video so far, so we're gonna stop it, upload it, all that other good stuff, and then we'll do the metabolic part. Break that down, come back. Thanks for watching in advance. Hey, how y'all doing?